So I am Marco Consolaro, the co-author of Agile Technical Practices Distill, and a co-founder of Alcor Academy, where we do training for professional software development teams. And the title of this question is inspired by Shakespeare, to TDD or not to TDD? That's the question. So in order to try to answer it, I'm gonna tell you a story, right? It's a story of ordinary madness. It happened in a big financial institution. International, I used to work in the UK building, but it was a German company. And I went in a team with more than 20 people, 2 teams, 20 coding months when I arrived, 0 deployments. That was scary. As an expert software crafter, you have been hired to help the team. So you join, you get inside the building, but soon after, more bad news. The project has been red flagged, which meant it will be defunded in 6 months, unless they will show something. Mission? Impossible, right? Well, what would you do? A small team was able to get from 0 to hero in those 6 months. This is the story of how it happened using TDD and much more. So, once upon a time, there were 2 crafters. They met inside this madness. They apparently were the only people seeing problems in that team. Right? They were continuously raising problems. But the other people say, no, it's no problem. No, you are fool. You just see ghosts. And then when these red flag arrived, everybody in the team was just, okay, bad luck. They were cleaning their CV, calling the recruiters. They were already doomed, right? And so they were already thinking about the next job. But not the 2 crafters. The 2 crafters were like, wait, we have 6 months. We can do a lot of things in 6 months, right? So they realized there was a part of the backlog that was left untouched. It was upstream. It was supposed to be developed before, but no one touched it because it's the boring stuff, right? No one wants to do the boring stuff. So they were like, what if we ask the management to give us, me and you only, that backlog in 6 months' time? I bet we can do something about that. And so they went to the management. And desperation made the impossible possible. Management say, yes, do it. ASAP. And actually, there's still some budget to hire 2 people if you need it, right? They were desperate. And so these people started to plan. And they needed a great team, right? But they have very little time and a lot of challenges. They really wanted to pick a couple of developers of the bigger team, right? Because 6 months, you don't have time to recruit really good crafters. In that time, you spend half of the time doing interviews. They couldn't afford that. So they wanted to try to pick somebody inside that team. But the main challenge was, I tell you the challenge to you. Do you really know TDD? Or Jimi Hendrix will say, are you experienced? Because in that team, everyone pretended to know its own version of TDD. They were like, yeah, we do TDD. Yeah, we do TDD, of course. Then you look at the code, and everyone pretended to do TDD in a different version. And so there was just tests around, but no one trusted the test because everyone trusted only the test that he wrote, not the test that other wrote. And the tests were all different, and it was impossible to understand, and that was a big problem, right? It's a little bit like karate.
Right.
Sir, ready?
Well, yeah, I guess so.
And your son must talk. Walk on the road. Walk right side, safe. Walk left side, safe. Walk middle. Sooner or later, get the squish, just like grape. Here, karate, same thing. Either you karate do yes, or karate do no. You karate do gesso, just like grape.
If everybody know TDD gesso, what could possibly go wrong, right? So, what is TDD, right? The problem is that TDD has evolved in time, but its definition has not. Are we talking about what Kent Beck did in the beginning, or are we talking about the umbrella of technique that evolved from that? And this is a problem. If we don't clarify what we mean, everybody says, oh yeah, I'm doing TDD. And then it's TDD, guess so, right? So what is TDD? Let's see some history so we clarify what that stuff is. It starts from back in the days, right? Start with the ideas of Dijkstra. If a developer adhere to the discipline to produce correctness proof as he programs along, it will produce programming proof with less effort than programming alone. This is TDD. But at the time of Dijkstra, they did it with punch cards. So it wasn't that effective. Plus, Dijkstra wanted to have a formal proof of correctness. And that is good in theory, but it's not pragmatic. We will see later. Instead, that TDD has a lot of pragmatism. Right? It's just good enough what we need, not a formal proof. So, Kent Beck, his dad was a programmer. He had books about programming, and he read books talking about this idea, and so it was like, wow, but now code is much easier to do, right? If we had just a framework where we can run our tests, then all that effort would be much easier. And that's how the idea of test-driven development started, 2002. And test-driven development is just a method, a way to move forward. It tells you a procedure so that you can expand your production code step by step, little bit by little bit, steady progress, right? And that's it. But, it doesn't answer many questions, right? For example, how many tests do we need? TDD says, up to you. How big or small the unit? Well, you know what? Up to you. Where do we start from? Guess what? You tell. What does TDD say? Up to you. Right? So, it's a method that is useful, but we need a little bit more, right? However, the principal heuristic for me about TDD, how many tests do we need? As few as possible, to reach a satisfactory level of confidence, right? That's it. Right? If we do too much, we have different kind of problems. If we do too little, we have different kind of problems. We need to have that right balance. That's why you need experience, because there's not a book that tells you what's the right amount. It depends on your context. It's a little bit like this, right? It's the rule of Pareto applied. So let's suppose we have the effort, and we have in the y-axis the confidence we have. Perfection is there, we can't reach it, because neither Dijkstra could achieve it, right? Formal proof, difficult, can't achieve perfection. But we can achieve good enough. And the thing is that the effort to do good enough, it's kind of 20%, then arriving close to a symptom. And this is the Pareto principle, right? We need to apply the Pareto principle when we do TDD. And also the Agile principle, try to remember that simplicity, the art of maximizing the amount of work not done, right? The waste part is essential. So our crafter have some wisdom for you. Steady progress, not perfection. So let's see. It's a little bit like this. Rabbit versus turtle. Who's gonna win? Oh, lost focus. Might be doing code review. Turtle instead slowly, step by step, steady. Yes. Now she tried to make the rabbit focus. Focus go. And the noise of the people lost focus. And turtle is gonna win. And our development efforts are the same. Delivering fast is not about top speed. Delivering fast is about continuous, steady progress. That's what TDD try to give you, a way to continuously, steady do progress and never stop. You need experience. Then, after Kent Beck, came the London School of TDD. That is an evolution from the idea of Kent Beck. And they try to answer the other question, right? How big or small the units? And where do we start from? That's the question that London School wanted to answer. And that happened in a few years later, right? With acceptance test-driven development, is also called. The technique explained by Steve Freeman and Nat Price in Growing Object-Oriented Software Guided by Tests, right? And here, basically, they say, well, we can start from the outside. We can start close to the user and have a bigger loop of acceptance tests that then drive what we do and where we start from. And then inside, we can fall back to the classic TDD cycle of Kent Beck. So we have a bigger loop and then a smaller loop for the internal components. London School wants to answer, where do we start from? We start from the user. So from outside to the inside, following the user journey. That's why it's also called outside-in development. And this is itself an evolution from the idea of the North with behavior-driven development, right? The North say that doing the thing right is not enough. Because many times the bug don't come from incorrectness of the code, come from incorrectness of the requirement or misunderstanding about the requirement. So what he came out with was with very well-defined way to agree with the business about the requirements. Actually, better if we can write those requirements in a form of acceptance criteria. So we can run them in code and actually use it for the acceptance test-driven development, bigger loop of acceptance test-driven development. And the idea was essentially, this is a chart that we have in our book, that the right product is up there. The right thing built right? Good design and the product that is what the user wants. And then we have a few different categories of bugs, right? We have the classic bug is category number 1, right? The requirement is correct, but the code is wrong, right? And this is all these kind of bugs. But then we have bugs category 2 and 3, right? Category 2 and 3 are different. Category 2 is the requirement is incorrect or incomplete, but the code is correct, which is irrelevant because the code does something else. And then we have category 3. The requirement is correct, but it is misunderstood by the developers. So the code does something else, right? And these are the real problems. So classic TDD solve bugs of the category 1. BDD, acceptance test driven development, solve category 2 and 3. And this is how our crafters wanted to work, right? They didn't want bugs. They want 0 bugs. They actually wanted to achieve 0 bugs. And many say, oh, it's impossible, right? Instead, somebody in the past said that if it's not possible to reduce the number of defects, there is a lack of ability. We can say bugs in our domain. If it's not possible to get too close to 0 defects, then there is a lack of perseverance. It's quite understandable. If we are able to reduce the bug, means that we have the ability to do it. But then if we don't care anymore, at a certain point, well, some bugs still stays there. Instead, if we really want to go to 0 bug, we need to, on one side, understand what category a bug is, so you know where you have to improve your process in order to have less of them. And this is a quote from Taiichi Ono, one of the main actors of the Toyota production system. So it's quite old, but in cars, actually, they achieved a lot of defect reduction compared to anyone else. So these crafters had a really clear idea how they wanted to work. It works like this. It worked like this in their team. They wanted to start from a user story, but the user story in their mind, they were just a placeholder for a conversation. They were just ideas, right? We prioritize the ideas, but we don't analyze them too early. Otherwise, we lose focus. We can't remember the conversation. We want to analyze it just in time with the 3 or more amigos, right? Essential, the developer, the business analyst, and the quality assurance, but can be also there an architect, security, more developers, anyone that want to understand the story firsthand. And what do? They use BDD. With BDD, they produce scenarios and acceptance criteria. Essentially, it's an agreement with the business about what that story is. And it's written inside the code, not Jira. We did not want to use Jira. They hate Jira. So they were like, no, Jira, let's write it in the code because then we have to develop it. It's quicker. We don't have time. And, they didn't have time, so no one dared to say, no, the quick. And so they did it. And after the acceptance criteria are prepared, with acceptance test-driven development, the development start developing and make all the acceptance criteria green. And that's sure that the business is happy because the business helped to produce those criteria itself. So either they were drinking while doing that, or the business agreed that the tests are correct. And so if it's green, we can trust them. And then inside, we have the double loop. So acceptance test outside and classic TDD inside. That's what the crafter meant for TDD. But in that team, was no way. They couldn't find anyone. So what did they do? They accepted the proposal to hire somebody. But they did it because they looked into their networks of crafters to see if somebody was available. And luckily, they found 2. So in 3 weeks, the other 2 crafters joined them and went on board. Thing is that it's not just Rome that wasn't built in one day. Also, TDD wasn't learned in one day. And that's the problem. It takes time. You have great reward, though, right? Loosely coupled design. If you can test it, your design is a little bit less coupled. Doesn't mean It is good, but it's definitely better if it was highly coupled. Up-to-date documentation. If you write your test well, where they speak the language of the business, actually you can read what the code does from a functional point of view. And it's very, very useful, especially because they need to be green. So you can trust that they do what they claim, because otherwise they wouldn't compile. The problem with documentation is that it gets stale very quickly. And then no one wants to make it up to date. And another is that you don't spend hours debugging anymore, because you just debug a test. And debugging a test is much quicker. You have business alignment. We have seen that using these techniques improve the way that we find understanding with the business. And in my opinion, the best of these advantages is courage, right? Courage to deploy on Friday night. If your tests are green, why shouldn't you? If you don't trust your test, well, maybe what's the point of doing the test, right? So this is the rewards you have. And our crafter, pearl of wisdom here is hone your craft and always mind the Danny Krueger effect. What is the Danny Krueger effect? It's this, right? It's the boost of confidence we have as soon as we get a little bit better in learning something. And we get to the peak, right? This is, you can see some people at this stage because they go on social media and say, TDD is a silver bullet, right? And usually, it's common. Everybody passes through these stages every time you learn something. Then once you realize that these things is like this, then you might try to avoid to be too much confidence too early. But then usually reality strikes and punch you in the face. And then the risk is that you go down in the valley of despair. And this is when those people go to social media and say, TDD doesn't work, right? Then eventually, with experience and with effort, they go up to the slope of enlightenment, and little by little, they go toward expertise, plateau of sustainability. You can recognize these people because they don't go on social media to talk about TDD. So, the Danny Krueger effect in our industry is making disaster. This is a stat from 349 interviews for a job requiring TDD. So 100% of these people claim to know TDD. The truth is that 18% can't even write a test. 56% can write a test after the code. 24% can write a test before the code, but only 2% apply correctly the classic TDD as per Kant-Beck book. These stats are from a great crafter for Seattle, right? It's Steve Kuo. It's a LinkedIn post. I had a nice chat with him, so follow him on LinkedIn if you like this content. The problem is that the enemy of knowledge is not ignorance, it's the illusion of knowledge. This is a quote from Brandolini, Alberto Brandolini, and this is the illusion of knowledge. Freddy Krueger, I think the Danny Krueger effect is named after this character. But then there is another challenge, which is TDD enough? Because TDD is a great technique, but no. TDD is necessary, but not sufficient. In that team, everyone was working alone without a shared strategy. And that was a bigger problem. How can you do a great job in such a big team if everyone do a little bit what he wants? It's impossible. Furthermore, there's more than TDD. There's a lot of practices that help to make TDD work, and those were all missing in Azure in that thing. Right? So our crafter needed to put in place all these kind of techniques. They started with continuous integration deployments, right? Yeah, more than a year, you deploy nothing to production, it's not acceptable. So what they did, first thing they did, well, let's create this pipeline and push something to production, right? The team of before, working my machine, right? Let's do a demo. Yeah, there we go. Look, business, this is the demo in the local machine, right? It's a problem because it doesn't need to work in the local machine, it needs to work in the production environment. It's different, right? So, parallel wisdom, done is when the customer loves it. And so they put together a very pragmatic way to work. They were working together with the business, writing these criteria, having ideas, prioritize inside the backlog, then with the process I've told you before, code, test, and then deploy live. So the business team could have the demo on the real environment. And then they just had to monitor that the environment was working properly. So you made it, you run it. Right? They started like this. And they did the working skeleton in the beginning. Right? To do a very nice pipeline in the beginning, you can just write an end-to-end functionality completed with all the integration points. Right? This is working skeleton, an idea from Alistair Coburn. And then Dan Nord evolved in the idea of the dancing skeleton to write one little functionality, forcing to touch all the integration points. And why do you want to do that? Because you want the problem to surface as soon as possible when you have the least amount of code there. Right? Integration points are painful, we know that. So let's solve that problem in the beginning, because once that's solved, then we can focus on our design. If we grow the code and then integrate, we have a much harder life to understand what the problem is. Is the problem of our code? Is the problem of the integration? Every time you have to dig. No, let's do the integration straight away. So that then we know the problem are most probably problem of our design. So automate everything to go to production without effort. And then they wanted to do another technique, simple design. Simple design is fundamental. Also Dijkstra, back in the day already understood it, right? In programming, simplicity and clarity are not a dispensable luxury, but a crucial matter that decide between success and failure. Right? That's fast design, right? So, good design is simple design, and it works a little bit like this, right? The orange one is bad design. Bad design, they start like Formula One. All writing code in the beginning, they show the business a lot of functionality. Right? Because it's easy if you have no code there. The cognitive amount in the beginning is not big, so you can handle, right? Developers are smart people, but they think that it's all about handling complexity. Unfortunately, we are human. There is a limit of the complexity you can handle, even if you are a genius. And so they start really fast. Instead, who do good design in the beginning, they start to slow down because they want to tackle all the problems. And that takes time. But then, in the long run, they try to keep things simple. It's not easy. You never do good design the first time you try. Because the good design is about context. It's not about rules. And you need to have the time to learn the context. And then you will have breakthrough. And you can remodel the things in a better way. So in the beginning, you pay the toll, right? And so if you don't have trust, or if the management is not desperate, it's easy to be tempted to move in the other side. And those two crafters in the beginning, the first story, took more than 3 weeks. Imagine all the other team, they were laughing. They were like, oh, These two heroes, right? They want to save the project they think to be great. More than 3 weeks for one story. They were laughing, right? But then, after the first story, we had to integrate with the login system to the server in Germany, and then save the token in the cache. It was a mess. Right? So it was really, really hard. But then the story started to fly in production. And in 4 months, they cleaned the backlog. The business, crazy. They couldn't believe their eyes. They deflagged the project. Project was green again. It would continue in the next year. They saved the whole team. And there were people of the other team at the end that went there and they were like, can I see your code? I like if it was, so we showed the code. And they're like, oh, wow, it's so simple. They thought to see crazy things. It was just readable, little classes, little methods, clear names, all the way. And they were, oh, wow. Right? It's simplicity. The thing is that you need to ask yourself, what is better? An egg today or a hand tomorrow? How long is your product doomed to last? If you need to do a prototype, you throw it away tomorrow, a script, something that is not worth maintaining, well, you can do what you want. But if you want a system that resists the battle of time, perhaps simple and good design is important. So, making it simple is not quite simple, but it pays off big time. Also, Dijkstra said, simplicity is a great virtue, but you require hard work to achieve and education to appreciate it. Right? People like to show cleverness, not to show simplicity. Here, the wisdom is improve your design skills. It's just a few principles you need to learn and understand, right? Just a little bit. So, the only thing you have to do is learn. The thing is that you can't force people to learn. The only thing you can do is you can create an environment where learning is likely to happen. So, hire curious people hungry for learning and create an environment where they are encouraged to do so, but not make it mandatory. They don't like it. And yeah, do not despair, because in a team of crafters, you'll never work alone, because they do collaborative programming. Right? In the team of before, people didn't really want to talk one another. They were just with this headset. Oh, what do you want? Upset if you ask them. So they didn't really want to talk. And that's a problem. It's a problem. Also Aristotle say, the whole is greater than the sum of its part as far as you collaborate. It's collaboration that makes it better. And to collaborate, you need to communicate. If you don't want to talk with your peers, you don't want to collaborate, and so you are not achieving the whole, right? And so they were doing pair programming all the time, right? Now this is funny, right? Because it's evident that that block is heavy. But the problem is that in our job, that block is cognitive load. And cognitive load is intangible. You don't see it, so it looks natural. Or they were doing a lot of more programming as well, because those crafters needed to train the BA and the quality assurance to work in this way. They never seen those techniques, so they were like, are you sure I can do it? Don't worry, we do it together, right? So there is also some rules to do more programming, so it's something to learn as well. And they use these with the BA and the QA because it's the faster way to learn. After 2 weeks, the BA and the QA were like, okay, developer, now we learn how to do it. Go do your job. Now we can do it by ourselves. They kicked them away. They didn't want them because they learn how to do it, right? Because in the beginning, you are scared. Maybe I am not able to do it. But then when you are able to, you realize it's much easier than what you don't. It's like, well, go do your job now because now we know what to do. And also Alan Turing, say, programming is a skill best acquired by practice and example rather than from books. It's like a little bit learning to drive a car, right? When you drive a car in the beginning, you have a checklist of things to do before you look outside, right? The pedal, the gears, the key, the mirrors. Now you are all expert to drive a car. You don't have a checklist. You always do this thing because it's a habit for you. You internalized it and became expert in driving a car. And good software design skills are very, very similar. Results are given by practice plus quick feedback. And quick feedback, we have seen the keynote about code review today, right? Collaborative programming is code review in real time. And the quicker the feedback, the more effective for learning. So that's why we love collaborative programming. So optimize your environment for learning together. But the last point I want to make is what was the real competitive advantage of that little new team? Before, finding consensus was impossible. So decisions were pushed by the leader. That's a problem because no one was committed to those decisions. Right? Oh, yeah. And then they did what they want. So there was not a clear strategy. It was not even a team. It was a bunch of people working together on the same thing. Instead, this little team had a competitive advantage, which was great teamwork. They were always working together. They were always together tackling the biggest problem. And they carry on until it was solved, and then they moved on until they solved the next big, great problem. Always together, all decisions were together. Everyone asked a question, everybody stopped and find if somebody was available to answer the question. They were continuously helping each other. And that was the competitive advantage. I agree with Patrick Lencioni when he say not finance, not strategy, not technology. It is teamwork that remains the ultimate competitive advantage because it's so powerful and so rare. And when there is trust, conflict becomes nothing but the pursuit of truth, an attempt to find the best possible answer. And that's how it works in our teams. Right? Essentially, we have reality there. This is group psychology. We have reality. Reality is objective. Right? It's one. We all see the same reality. And also knowledge is objective. Right? Let's suppose microservices, definition, blah, blah, blah. It's objective because it explains reality. The real problem is that our understanding instead is very personal. It's very personal because we have a unique mental model of the world that derives from our unique experiences. Every and each one of us have been living a different life. So he has a very unique mental model of the world. And so when we think about some knowledge, we can map it to something different. Maybe somebody says, microservices, AWS. So I say, no, it's hexagonal architecture. So I say, no, to me, it's serverless. And somebody, no, for me, it's just like SOA, but more granular. Somebody's like, no, it's Kubernetes. And somebody say, oh, I have no idea, right? So how can we grow this? How can we get better as a team? where we can have meaningful conversation and experiences. We try to understand each other, to understand where the mental models come from. And so through these experiences and conversation, we then have breakthrough. We have ideas. We have an enriched model. And then all the team, when think about microservices, think about the connection of all the elements that are put together by the group. And this is called collective mindset. The collective mindset are the beliefs, assumptions, habits, and attitudes that a group as a whole holds in common about its context. And it's important because it is the collective mindset of an organization that determines its overall effectiveness, productivity, and degree of success. This is a book from my friend Bob Marshall. And this gives us the winning equation. Team performance is a function of the collective mindset. So let's try to answer the question. To TDD or not to TDD? Up to you. But if you do, first, learn it properly. The only thing I can tell you is we have been teaching this technique to hundreds of developers. And I have never seen anyone that after he learned it properly went back to code as before. No one. No a single one. So always remember that ego is the ultimate killer on a team. That's ego. So stay hungry, stay curious, but for God's sake, stay humble. Thank you. Little communication. Little communication. If you are interested to learn this technique, we have a B2C training that starts the end of February in partnership with Advanced Coperta. And this is completely remote. It's going to be in Italian. And we are going to do live coding together for 10 lessons. We go from classic TDD to London School. So if you are interested, give it a thought. Thank you.
Thank you, Marco.